first lesson in the analytic geometry unit is on finding the midpoint and the length of a line segment. To find the midpoint of a line segment, you must find the middle, or what we call the average, of both the x and y coordinates of the endpoints of the line segment. So if we look at the diagram of this line segment, you can see that we have two endpoints. We'll call them A and B. It doesn't matter which one is your first and which one is your second. We'll call A our first point, which has an x and a y coordinate, and B our second point, which has an x and a y coordinate. To find the midpoint of line segment AB, we average the x coordinates by adding them and dividing by 2. And then we average the y coordinates by adding them and dividing by 2. And this will give us the x and y coordinates of the midpoint of the line segment. Let's move on to the length of a line segment formula, and then we'll do some practice questions where we find midpoints and lengths of line segments. So to find the length of a line segment, we can use a formula that is generated from our understanding Pythagorean theorem. So what we do is we turn the line segment into a right angle triangle by finding its horizontal and vertical components. We call the horizontal component the run and the vertical component the rise. We can calculate the length of the run by finding the difference in the x coordinates, and we can calculate the length of the rise by finding the difference in the y coordinates. And since this is a right angle triangle, we know that the sum of the squares of the shorter two sides is equal to the square of the longer side, which in this case is the line segment that we want the length of. So the length of line segment AB squared is equal to the difference in the x coordinate squared plus the difference in the y coordinate squared. And if we rearrange to isolate for the length of AB, we just move the squared to the other side, and we end up with the length of AB equals the square root of the difference in the x coordinate squared plus the difference in the y coordinate squared. Let's practice using those two formulas now. Example 1 tells us to calculate the length and midpoint of the line segment joining endpoints C and D. I'm just going to label the points on the diagram. And now I'm going to decide which of these 2 points I want to be my first point and which one I want to be my second point. It doesn't matter which is which, but if we assign each of them to be the first or second point, then we can follow the formula more accurately. I'll let point C be my first point. So I'll call that x1, y1, right? Each point has an x and y coordinate, and since that's my first point, I'll call that x1, y1. And my second point is point D, so I'll call those coordinates x2 and y2. Now if I'm going to find the midpoint of line segment CD, I'll short form that by saying the mid of line segment CD equals, I can find the coordinates of the midpoint by following the formula, which tells me to find the average of the x coordinates. And I do that by adding them and dividing by 2. So I'll do x1 plus x2 divided by 2. That'll get me the x coordinate of the midpoint. And I can find the y coordinate of the midpoint by adding the y coordinates and dividing by 2. So I'll do y1, which is -4, plus y2, which is 5, divide that by 2. And now I'll simplify the x and y coordinates. If I look at the x coordinate of the midpoint, 2 plus -3 is -1. So my x coordinate is -1 over 2. And my y coordinate, -4 plus 5 is 1, and that's over 2. So my midpoint is at -1/2, 1/2. If I were to plot that point, if I were to move to -1/2, 1/2, I would notice that that point is on the line segment, and that looks like that's right in the middle of the line segment. That's my midpoint. It's at -1/2, 1/2. Now I'll find the length of line segment CD. So I'll say the length of CD equals, and if I follow the formula for length of a line segment, I need to find the difference in the x coordinates. So I'll do x2 minus x1, that's -3 minus 2 squared, plus the difference in the y coordinates. So I'll do y2 minus y1, which would be 5 minus -4 squared, and that all needs to be square rooted. And let me actually simplify under the square root here. -3 minus 2 is -5, and 5 minus -4 is 9. Now I won't always show this step, but I think it's important for me to show it here to help you understand how this formula is actually going to tell us the length of the line segment. The absolute value of the difference in the x's is 5, and notice if I were to make this into a right triangle by drawing its horizontal and vertical components, The length of the horizontal component is 5 units, and the length of the vertical component is 9 units. And what we know based on Pythagorean theorem is that the sum of the squares of the shorter two sides, 5 and 9, should be equal to the square of the longer side, the line segment CD, which is what we're trying to find. So that's where this formula comes from. Now I know I said the length of this is 5, and here I see a -5, but when we square it's going to work out to the same thing. Just the absolute value of the difference tells us the length of the lines, and that's why Pythagorean theorem allows us to find the length of the line segment. But if we follow the formula, it'll all work out the way we want it to. So if I simplify under the square root, I have -5 squared, which is 25, plus 9 squared, which is 81. So 25 plus 81 is 106, so I have the square root of 106. That's the exact length. If I want the approximate length, I can evaluate that on my calculator, and I would get a value of about 10.3. And I don't know what units I'm in, so I could just write 10.3 units. Let's try another example. Example 2. We'll calculate the length and midpoint of the line segment joining A and B. So once again, let me label the points on the graph, and I'll choose point A to be my first point. So that's my x1, y1, and point B to be my second point. That's my x2, y2. If I'm going to find the midpoint of line segment AB, I need to average the x-coordinates. If I follow the formula, it tells me to do x1 plus x2 and then divide by 2. So 6 plus -3 over 2. And then to get the y-coordinate in the midpoint, I need to average the y-coordinates of my endpoints. So y1 plus y2 is -1 plus 7. And then I need to divide that by 2 to find the average. If I simplify this, 6 plus -3 is 3, so I have 3 over 2, which I suppose I could write as 1.5, but I'll leave it as a fraction. And the y-coordinate of the midpoint is -1 plus 7, which is 6 over 2, which 6 divided by 2 is 3. Let's check if that midpoint looks right on our line segment. The point 1.53 is right here. It appears to be on the line, and it appears to be right in the middle of the line. So it looks like we have the right midpoint. Let's now find the length of line segment AB. And to find the length, we need to square root the difference in the x's squared plus the difference in the y's squared. So we'll do the difference in the x-coordinates, and we'll follow what the formula tells us to do. We'll do x2 minus x1, so -3 minus 6 squared, plus the difference in the y-coordinates. And the formula says to do y2 minus y1, so I will do 7 minus -1 squared. If I simplify underneath the square root, I would have -9 squared plus 8 squared. If I collect those terms under the square root, I would have the square root of 145 as my exact answer. If I want an approximate answer, I can type that on my calculator, and I get approximately 12.04 units. And hopefully you remember why that formula works. Really what we did was we used Pythagorean theorem by turning this into a right triangle, and by finding the difference in the x-coordinates, we found out that the length of the horizontal component is 9 units. I get that from the absolute value of the difference of the x's, and I found out that the length of the vertical component is 8. I got that by doing the difference in the y-coordinates of the endpoints. And using Pythagorean theorem, we were able to solve for the length of the hypotenuse, which is line segment AB. Let's move on to example 3, and this is going to be the first one where I haven't given you a diagram, and actually I didn't give you very much room to work here, so I'll write small. We're going to find the length and midpoint of the line segment joining E and F. I noticed the x and y coordinates of my endpoints have some fractions involved, but if we follow the same formulas, and as long as you know the rules for working with fractions, we can solve this question the same way we did the previous two. I'll find the midpoint of EF, and maybe it'll be helpful for me to label these points as my first point, so I'll label E as x1, y1, and I'll make F my second point, x2, y2. If I follow my formula for midpoint, I need to average the x-coordinates by adding them and dividing by 2. So I have to do -5 over 8 plus 4 over 2. That will get me the x-coordinate of the midpoint. To get the y-coordinate of the midpoint, I need to find the average of the y-coordinates of the endpoints. I'll do y1 plus y2 over 2. That's 1 over 8 plus 3 over 4 over 2. Now notice in the numerators of the x and y coordinates, I have fractions being added. I'm going to need to get a common denominator. This 4, you can think of it as a 4 over 1, I need it to have a denominator of 8. So I will multiply that 4 over 1, top and bottom, by 8 to get an equivalent fraction that has a denominator of 8. And that gives me 32 over 8. And if I look at the y-coordinate of my midpoint, I look at the numerator, also fractions being added. My common denominator will be 8, so I'll multiply that 3 over 4, top and bottom, by 2 so that it has a denominator of 8. And that gives me an equivalent fraction of 6 over 8. Now that they have common denominators, I can add them. If I look at the x-coordinate, negative 5 over 8 plus 32 over 8, the rule for adding fractions with a common denominator is to add the numerators, negative 5 plus 32, which is 27, and keep the denominator. So I have 27 over 8, and keep in mind that is over 2, comma, the y-coordinate, I have 1 over 8 plus 6 over 8, that is 7 over 8, and that is also over 2. I have two fractions, and they're both being divided by 2. To divide a fraction by a whole number, there is a shortcut, but for our first time, it may be easier for me to rewrite those whole numbers of 2, to rewrite those as 2 over 1s. That way we've turned it into a fraction over a fraction. And when dividing fractions, the rule is you flip and multiply. So the 27 over 8, we leave that as 27 over 8, but we change it to multiply, and multiply by the reciprocal of the fraction in the denominator. So the reciprocal of 2 over 1 is 1 over 2. That'll give me the x-coordinate, and then the y-coordinate do the same. Leave the 7 over 8, times the reciprocal of the fraction in the denominator, which is 1 over 2. And now that it's written as multiplication, multiplying fractions is easy. Just multiply the numerators. 27 times 1 is 27. And multiply the denominators. 8 times 2 is 16. Looking at the y-coordinate, 7 times 1 is 7. And 8 times 2 is 16. So the midpoint is 27 over 16, comma, 7 over 16. Now I said there was a shortcut. Let me just rewrite the middle step here the way we originally had it. If you notice, when you have a fraction being divided by a whole number, the denominator of the fraction just gets multiplied by the whole number. 8 times 2, 16. And same thing with the y-coordinate. 8 times 2, 16. So that's a little shortcut if you want to use that, if you have a fraction being divided by a whole number. Let's now find the length. Remember, to find the length, I need to do the square root of the difference in the x-coordinates. So I will need to do x2 minus x1 squared. That's 4 minus negative 5 over 8 squared plus the difference in the y-coordinates squared. If I do y2 minus y1, that's 3 over 4 minus 1 over 8 squared. Now I already know how to get common denominators here. When I'm subtracting fractions, I also need common denominators. So I'm going to change that 4 to a 32 over 8. And I'm going to change this 3 over 4 to a 6 over 8. And now if I simplify, the rule for subtracting fractions is the same as for adding. We just subtract the numerators and leave the denominator the same. 32 over 8 minus negative 5 over 8 would be 37 over 8. And 6 over 8 minus 1 over 8 is 5 over 8. When you have an exponent on a fraction, you need to apply that exponent to the numerator and denominator. So I would need to square the 37 and the 8 in the first fraction. That would be 1,369 over 64. Plus, if I do the same thing to the second fraction, square the numerator and denominator. 5 squared is 25 over 8 squared, which is 64. And now I can get an exact answer expressed as a fraction. They already have a common denominator. So if I add the numerators, that would be 1394. Keep the denominator the same. Here's an exact answer. Now that fraction could be reduced, but for our purposes for this, that's fine. If we want an approximate answer, I can evaluate that on my calculator. And I get about 4.67 units. All right, there are two more examples left to do. The next one's a little bit different. It says if line segment AB has point A at 5, 7 and midpoint 4, 8, what are the coordinates of point B? So this one's different because for our line segment, I know one of the endpoints. We'll call this one here A. I know that's at 5, 7. I don't know the other endpoint. I don't know point B. Point B, I'm not sure what the coordinates of that point are. So I don't know what x and y are for that point. But I do know what the midpoint is. It tells me that the midpoint is at 4, 8. So our job in this question is to solve for what are the x and y coordinates of endpoint B. Now it may help if I choose whether B is going to be my first or second point, and same with A. I'll say A is my first point, my x1, y1. Therefore B is my second point, so it's my x2, y2. And now if I follow my formula for midpoint, I know that the midpoint, which is 4, 8, must be equal to the average of the x coordinates of the endpoints, and I get the average of them by adding them and dividing by 2. So x1, which is 5, plus x2, which we don't know, over 2. And the y coordinate of the midpoint, we would get by averaging the y coordinates of the endpoints. y1 plus y2, which is 7 plus y2, we're not sure what that is. Divide by 2 to find the average of them. Now let's separate this into two equations, one for the x coordinate of the midpoint, one for the y coordinate. The x coordinate of the midpoint is 4, and that's obtained by adding the x coordinates of the endpoint and dividing by 2. And the y coordinate of the midpoint, 8, should be equal to the average of the y coordinates of the endpoints, 7 plus y2 over 2. I now have two equations. I can solve each of these equations for the one unknown in each of them. The first thing I would do to isolate the variable is move the divided by 2 to the other side by doing the inverse operation, which is multiplying by 2. 4 times 2 is 8, so I have 8 equals 5 plus x2. And if I'm looking at the y-coordinate equation, 8 times 2 is 16, so I have 16 equals 7 plus y2. And now in each of them, I just have one step left to isolate the variable. For the x-coordinate, I'll just subtract the 5 to the other side, and I would have x2 equals 8 minus 5, which is 3. And to isolate y2, I just need to subtract the 7 to the other side, and I would get y2 equals 16 minus 7, which is 9. So I've now discovered that the coordinates of B are actually 3 and 9. And this makes sense because if I were to look at the x-coordinates of the endpoint, 3 and 5, of course 4 is in the middle of 3 and 5. And if I look at the y-coordinates, 9 and 7, of course 8 is in the middle of 9 and 7. So it appears we have the correct coordinates of endpoint B. Our last question, example 5, says we have triangle DEF, and it gives us the coordinates of the vertices of that triangle. And it asks us to, in part A, classify the triangle by side length. So I'm going to need to know the length of all three sides of this triangle to decide whether this triangle is scalene, isosceles, or equilateral. If all three side lengths are different, it would be scalene. If two of the side lengths are equal, it's isosceles. If all three side lengths are equal, then it's equilateral. So let's find the length of all three sides. Let's start by finding the length of ED. Let me label the coordinates for E and D. And I'll choose point E to be my first point, my x1, y1. Point D to be my second point, my x2, y2. And now I'll go ahead and follow the length formula, which tells me to do the square root of the difference in the x-coordinates squared. So 1 minus negative 3 squared, plus the difference in the y-coordinates squared, 3 minus 2 squared. If I simplify under the square root, the difference in the x-coordinates is 4 squared is 16, plus the difference in the y-coordinates is 1. 1 squared is 1, so 16 plus 1 is 17. Therefore, the length of line segment ED is root 17. I'm not interested in the approximate value of this. It's 4 point something. Having the exact value will be better, actually, when we're trying to classify this based on side length. Let's now do the length of one of the other sides. Let's do EF. So I'll make F, I'll label that point negative 2, negative 2. Since I already have E as my first point, x1, y1, I'll just leave those labels and make F my second point, my x2, y2. And if I follow the length formula, I'll do the square root of the difference in the x-coordinates squared. x2 minus x1 would be -2 minus -3 squared, plus the difference in the y-coordinate squared. y2 minus y1 would be -2 minus 2 squared. Simplifying underneath the square root, the difference in the x's is 1, the difference in the y's is -4. 1 squared plus -4 squared is once again root 17. So those two side lengths are the same. So this triangle is not scalene, it's either isosceles or equilateral. That will depend on what the length of line segment DF is. For line segment DF, I suppose D should be my first point. So I'll have to change those labels to make this x1, y1. And I already have F labeled x2, y2. Following the length formula, I do the square root of the difference in the x coordinates squared. x2 minus x1 would be -2 minus 1 squared, plus the difference in the y coordinates squared. y2 minus y1 would be -2 minus 3 squared. Simplifying underneath the square root, the difference in the x's is -3, the difference in the y's is -5. -3 squared plus -5 squared is 34. So this would be the square root of 34. Now that I know that two sides of this triangle are equal, I can classify this as an isosceles triangle. Part B just asks us for the perimeter of this triangle, and it says to round it to the nearest tenth. We just need an approximate perimeter. If I want the perimeter of a triangle, I just have to add the length of the sides. The perimeter would be equal to root 17 plus another root 17. I suppose I could have written that as 2 root 17. Plus root 34. And it asks me for the approximate value, so I'll evaluate that on my calculator. And that gives me a perimeter of about 14.08 units. Part C asks us, is it a right angle triangle? Give proof. Well, if I look at the triangle, it kind of looks like this might be a right angle here, but we don't want to have to just guess, and we actually don't have to calculate any angles. What we can just do is check if Pythagorean theorem holds true. We know that for all right angle triangles, the sum of the squares of the shorter two sides equals the square of the longer side. So let's check. I'll use the shorter two side lengths as a and b. So I would have root 17 squared plus the other root 17 squared. And we're checking to see, is that equal to the square of the longer side, which is root 34? Is the left side of this equation equal to the right side? Well, hopefully you know that square rooting and squaring are inverse operations of each other, so they're just going to cancel out. So for each of these terms, the square root and the square cancel out, and I just on the left have 17 plus 17, and on the right I have 34. And of course 17 plus 17 is 34, so the left and right side of this equation are equal to each other, which tells me that Pythagorean theorem holds true, which means that this is in fact a right angle triangle. And that's the end of the lesson. Make sure you try out the practice problems.